Hey guys, this is the review from Module 11, uh, and it's the review for 11.1 to help you with your quiz. All right, so let's get started here. All right, so we're going to describe a two-dimensional figure that results from slicing a three-dimensional figure, and we're going to slice it parallel to the base. Of course, the base, this is a cube, so we're just going to take it and slice it, and what shape will result? And of course, if you slice it parallel, you're going to get that same exact shape as the base. So hopefully you know that that base is a square. Of course, sketch the plane that slices the figure. And if you need another hint, it's going to be the same shape as the base. Okay. All right. And moving on, number 2. Okay, let me clear that off. All right, now describe the two-dimensional figure that results from slicing the three-dimensional figure sliced perpendicular to the base. So of course, perpendicular to the base, we're going to make a right angle, and it says through the vertex. So that's actually important. So we're actually going to start at the tip, and we're going to go straight down. So what shape results right here? Okay, and hopefully you see that that is a triangle shape. Okay. Okay, obviously you can sketched it, and perpendicular place, the vertex always has the same shape. So you can see that the vertex there are triangles all the way around it. So this is a triangle. Check it, we're good. Okay, let's clear this off. All right, moving on to the next question. Question number 3. All right, describe the two-dimensional figure that results from slicing a three-dimensional figure, slice perpendicular to the base, but not through the vertex. So we're gonna do the same thing, but we're not gonna go through the right here. We're actually gonna go down here. So we went like that there. Okay. Now, what shape is actually made there? Okay. Well, there's actually two different shapes that are made there. One, definitely a triangle. Okay. It's definitely still a triangle. Okay. You slice the pyramid perpendicular to the base and parallel to one of the edges. So that's one way I could have done it. Um, let's actually clean this up a little bit. Maybe a little easier to see if I did it. And I'm not going through there, but I'm going like right here. One way you could see it is that possibly could be a triangle. But the other thing that could possibly be, because you can slice the pyramid perpendicular to the base and parallel to one of the edges of the base. So like this is the edge. So if we did it parallel, what shape is this right here? And that shape is actually a trapezoid. So you could have created a triangle or a trapezoid with that one. Okay. So two distant sides of the pyramid. So that actually was a trapezoid or a triangle, and hopefully you can see my trapezoidal shape. If you're not familiar with the trapezoid shape, look one up. We've actually seen that question before. Okay. All right, let me clear this off. And moving on to question number 4. All right, tell whether the slice must be parallel or perpendicular to the base to make the given cross section. Select the answer from the drop-down list to correctly complete the sentence. A blank slice of a pentagonal pyramid results in a pentagon. So if I want another pentagon, I've got to go parallel to the base. Okay, so if you drew yourself a three-dimensional pentagon and you want another pentagon, it's like making a cake, right? If you want that cake to look like the top and the bottom, you've got to slice it parallel or slice through like the side of the cake rather than top to bottom. Okay. Tell whether the slice must be parallel or perpendicular to the base to make the given cross section. Select the answer again. All right, a blank slice of triangular prism results in a triangle. Okay, so again, same thing. If I have a triangle and I want another triangle, I better slice it parallel. And moving on, question number 6. Okay, a blank slice of hexagonal pyramid results in a triangle. Well, if I sliced it parallel, we know it's going to create a hexagon. So this one is perpendicular. All right, a sphere has a radius of 12 inches. Okay, describe the cross-section formed by slicing the sphere through the center and select the answers from the drop-down. Okay, all right, so I've got this sphere here, okay? And I know it has a radius of 12 inches, okay? If I slice through the middle of the sphere, okay, like a basketball, a baseball, a lacrosse ball, a bowling ball, and I look at it, I look at the piece I sliced, it's going to be a circle in shape, right? And what about it is going to be 12 inches? It's still going to have a radius of 12 inches because I went right through the center. Okay. Now let's describe the cross section by slicing the sphere many times, each farther from the center of the sphere. Okay. So if we continue to slice it further from the center, will it still be circles? Sure, but what's going to happen to those circles? Okay. What will we see about the radii? Well, think about when you slice an egg using an egg slicer. The middle piece of that egg is the biggest egg, right? Is the biggest slice of the egg. But as you get um, towards the edge of the egg, it's smaller. Or think about if you cut a tomato um, or you cut an orange and you cut it into slices. The slices closer to the edges get smaller. So the radii are going to decrease, okay, as you move away. Okay, hopefully that makes sense. Okay, moving on. Question number 8. What cross sections might you see when slicing a cone that you would not see when slicing a pyramid? Okay. All right. So if you slice a cone, what's the bottom of a cone? Okay. A face of a cone. Face of a cone is a circle, and you're not going to get a square or rectangle out of a cone. Okay. You need to look at the hint. Okay, that's just basically said look at the bases: prism, pyramid, cone. Okay. All right, moving on to question number 9. Okay. All right, let's select all of the following three-dimensional figures that could have a cross-section of a triangle when sliced parallel to the base, perpendicular to the base through the vertex, or perpendicular to the base, not through the vertex. Okay. So, all right, so I want to select all that could have a cross-section of a triangle. So we've already seen this one. Okay, again, you could have a triangular prism. Okay, you can make that. And then the other one that contains triangular would be a triangular prism. So again, the keyword being triangle. You're looking for ones that could have a triangle here. Okay. All right, moving on to the next question. All right, so it's going to ask me to match some stuff up here. Okay. All right, match each description of slicing a three-dimensional figure with a resulting two-dimensional figure shown, okay? All right, slice a square pyramid parallel to the base. So if you have a square pyramid, you slice it parallel to the base, what would you get? Well, it's a square pyramid, so you're gonna get a square, right? Slice a non-square rectangle prism parallel to the base. Well, guess what you're gonna get? You're gonna get a rectangle, right? Slice a square pyramid perpendicular to the base through the vertex. And of course, you're going to get a triangle. Actually, just talked about that in the previous problem. And then a pentagonal process of elimination. But of course, when you slice a pentagon prism parallel to its base, it's going to create a pentagon. Check them. Of course, you can look at the hints and check. And we're good. All right, question 11. All right, describe the cross sections made by slicing a hexagonal prism parallel to and perpendicular to the base and select the answers. So parallel, of course, you're going to get a hexagon. And then perpendicular, what will you get? Okay, well, you're going to get a, it's going to be a triangle, it's going to be a, no, it's going to be a rectangle. Okay, it's going to be a rectangle. Oops, the hexagon, rectangle. Okay, check it. It's good. All right, moving on. Draw a quadrilateral of two pairs of parallel sides, congruent sides, and four right angles. Does this have four right angles? No. Does this have 4 right angles? No. Does this have 4 right angles? Yes. Does this have 4 right angles? No. There's our answer. Yeah, I'm not sure why it says that one's wrong because that's 100% correct. So moving on. That's definitely right. So error in the program there. All right. Find the composite figure. So you can do this a couple different ways. You could draw a line here. You could draw a line there. I'm going to draw it right there. Find the area of that one. That's 12 times 6. So if you calculate there, 12 times 6, of course, is 72. And then what's this area up here? Well, this is from 6 to here. That's 6 there. That must be 6 times 6, which is 36. And I add those two together. And I get 108. Check it. We're good. And that is the 11-1 review. You should be ready to move on to 11-2 review before you take your quiz. Thanks for watching.